Hello guys, welcome to lecture 4. Today we will read about random variable and also discrete random variable, how to find its mean and variance and some of its properties. Okay, let's get started. I will clearly explain everything point by point. We also have examples by which the concepts would be very much clear. So let's get started. What is a random variable? Let's know first. Many variables of interest in a system are not expressible on explicit function of time. All such variable on explicit function of time, all such variables are classified as random variable. These are implying uncertainty about their exact nature. Okay? Random variable are of two types, discrete and continuous. And random variable deal with probability theory, that is discrete probability theory and continuous probability theory. Let x be a random variable, then function f of x, which is equal to p of x less than equal to x, is called distribution function of x. Mean or expectation of x is equal to mu, which is also e of x, whose value is x of ai multiplied by p of ai. Suppose the random variable is 0 and the probability related to it. Okay, then addition, so on, x of an, probability of an, which is equal to summation I equal to 1 to n x of ai into p of ai, where s is the probability space a1 a2 so on an. And variance of x, which is also called var of x, which is sigma square, whose value is e of x square minus e of x whole square, and its standard deviation of x is root over positive square root of variance of x, which is sigma. We have an example. Find expectation of the number of points when a fair die is rolled. By this example, we can understand the concept better. Expectation or mean is the same. Okay? So what are the possibilities if die is rolled? What are the random variables actually? 1, 2, 3, 4, 5, 6 is the random variable. And the probability associated with it. If 1 is rolled, the probability associated with it is 1 by 6. Similarly 2, 1 by 6. 3, 1 by 6. 4, 1 by 6. 5, 1 by 6. 6, 1 by 6. The product. We have the formula, right? X of ai multiplied by p of ai, right? So x of ai 1 multiplied by 1 by 6, which is 1 by 6, 2 multiplied by 1 by 6, 2 by 6, similarly 3 by 6, 4 by 6, 5 by 6 and 6 by 6. Expectation is summation of the product, right? Summation is there. So 1 plus 2 3 plus 3 6 plus 4 10 plus 5 15 plus 6 21, 21 by 6, which is 7 by 2. So the expectation of the number of points when a fair die is rolled is 7 by 2, which is 3.5. Now we will see next example. What is the expectation of the number of failure preceding the first success in an infinite series of independent trials with constant probability of success p in each trial? What does this mean? That the expectation or mean of the number of failure preceding the first success, that means that the number of failures preceding the first success, there is a success after some number of failures in an infinite series of independent trials. So one trial is not related to the other. Constant probability of success, the probability of success is p in each trial. Okay, the solution given, let p be the probability of success and q be the probability of failure, which is equal to 1 minus p. Let x be the random variable representing the number of failure preceding the first success. Okay. Since an infinite series of independent trials are conducted, then x equal to 0, 1, 2, so on. Probability of x equal to x, which is probability that there are x failures preceding the first success. First one q, that is failure, then failure, continuously failure, then after that we have success for x number of times, right? So which is equal to q to the power x into p. Now what it is asked? Expectation, which is mean, which is summation x equal to 0 to infinite, since infinite series, x into p of x equal to x. So the random variable multiplied by the probability associated with it, which is equal to x equal to 0 to infinite, x, p of x equal to x is q to the power x p, q to the power x p. Now what is the value? 0 is considered, then it is whole 0, then we will start with 1 q to the power 1 p plus 2 q square p plus 3 q cube p plus so on. Taking qp common, we have 1 plus 2q plus 3q square plus so on. Actually, by the extension of binomial theorem in infinite series, 1 minus q to the power minus 1 is 1 plus q square so on for mod q less than 1. If we take the differentiation of this is 1 minus q to the power minus 2, and differentiation of 1 plus q square is 0 plus 1 plus 2q plus 3q square plus so on. So that is why this is represented as 1 minus q to the power minus 2. So its value is qp multiplied by 1 minus q to the power minus 2, which is qp by 1 minus q square. So 1 minus q, we know that it is p. Of course, if p plus q is 1, then p is 1 minus q, or q is 1 minus p. So 1 minus q is p, which is p square. So the answer is q by p. Next, the Bernoulli probability law with parameter p in which 0 less than equal to p less than 1 is defined by a random variable x taking the value 1 with probability p and value 0 with probability q. Find the mean and variance of x. Okay. The two random variables given is 1 and 0, and the probability related to it is, if 1 is the random variable, its probability related to it is p. If 0 is given, the probability related to it is q. So we know that the product is p, 0 into q is q. Expectation is p plus 0, which is p. Hence mean is e of x, which is p. Now to find the variance, we have the formula e of x minus e of x square. E of x square minus e of x whole square. Okay. To find e of x square, we have to perform the x square. I have to find the x square. So 1 square is 1, 0 square is 0. P of a, p and q. Its product is p and 0. So e of x square is p plus 0, which is p. The variance is e of x square minus e of x whole square. E of x is p and e of x square is p. This is p minus p square. So taking p common, we have 1 minus p. 1 minus p is q. So the answer is pq. Now what is absolute frequency? Let a value xi is repeated fi times, then fi is called frequency or absolute frequency. Let n is the sum of all frequencies fi, then fi by n is called the relative frequency. Okay, I equal to 1 to so on n. Now, and the sum of all relative frequencies f1 by n plus f2 by n plus so on fn by n. So the denominator is same, The numerator adds up f1 plus f2 plus so on fn by n, and you know that sum of this, all this is n. So n by n is equal to 1. Now coming to discrete random variables. Fine. Let x be a discrete random variable taking on the values xi with corresponding probabilities pi, which is f of xi. Function f of x is called probability density function. It is convenient to present the values of discrete random variable and the corresponding probabilities in a tabular form as follows. If x1, x2, so on xn are the random variables, then the functions, probability density functions related to it is p1, so on pn, and its sum is 1. Okay. So the cumulative distribution function of a discrete random variable x, denoted as f of x, is defined as f of x equal to p of x less than equal to x, which is equal to summation x1 less than equal to x f of xi. By an example, we will understand that. So for a discrete random variable x, f of x satisfies the following properties. Okay. 0 is less than equal to f of x is less than equal to 1. If x is less than equal to y, then f of x is less than equal to f of y. The cumulative distribution function can be used to calculate the probabilities in this following way. Cumulative distributive function can be used to calculate the probabilities. P of a less than x less than equal to b can be written as p of x less than equal to b minus p of x less than equal to a. And we know that p of x less than equal to b is f of b, and p of x less than equal to a is f of a, right? Here, from here. The mathematical expectation of random variable x, or just expectation or mean value of x, or just mean of x, is denoted by e of x and is defined by e of x equal to summation I equal to 1 to n xi f of xi. Similarly, as previously we are calculating xi p of xi. The alternative notation is mu x or mu are also often used. We have an example. Suppose an insurance company pays the amount of 1000 euro for lost luggage on an airplane trip. From past experience, it is known that the company pays this amount in 1 out of 200 policies it sells. What premium should the company charge? So defining the random variable x as x equal to 0, if no loss occurs, then the probability with it is 1 minus 1 by 200, okay, which is 0.995. And for x minus 1000, which is loss of 1000 euro, its probability is 1 out of 200, which is 1 by 200, which is 0.005. So you have the table for random variable 0, the cumulative function is 0.995, and for random variable minus 1000, the cumulative function is 0.005. Okay, then let us find what is the premium that the company should charge. The expected loss to the company is 0 multiplied by 0.995 plus minus 1000 multiplied by 0.005, which is minus 5, right? Thus the company must charge 5 euro to break even. Now some of the properties of mean. E of c of x is equal to c of e of x, c being a constant. Here is the proof. E of c of x can be written as summation I equal to 1 to n c x into f of xi. C being the constant, we can take it out. So c summation I equal to 1 to n x into f of xi, which is c e of x. Okay. E c of x plus d is equal to c e of x plus d. What is the proof? E c of x plus d can be written as summation I equal to 1 to n c of xi plus d multiplied by f of xi. summation I equal to 1 to n c of xi multiplied by f of xi plus summation I equal to 1 to n f, here it would be d into f of xi. Okay, we can take the constant out, c into summation I equal to 1 to n xi f of xi plus d into summation I equal to n of f of xi. This is c u of xi and this is 1, so d into 1 is d. The variance of a random variable x is denoted by var of x and is defined by var of x equal to e of x minus e of x whole square. The alternative notation is sigma square x and sigma x square are also often used for variance of x. Okay, for today I think it is enough. We will see in the next video more about it. So I hope you have understood. If there is any doubt, you can ask me in the comment section. Today I have not made the note, I just directly taught from the book. So I think it is okay. So if there is any doubt, you can ask me. Thank you for now. Have a nice day.